Welcome to my video on quadrilateral angles and side measures. So the sum of the measure of the interior, which is inside angles of a quadrilateral, is 360 degrees. So what we're going to do is we're going to look at three quadrilaterals and we're going to find the missing angles. And we know that all the angles add up to 360 degrees. So let's look at example number 1. We have 98, 95, and 104. So we're going to add those up, and if we add x to it, it will equal 360 degrees. So watch how I set this up. We have 98 plus 95 plus 104 plus x will equal 360 degrees. So now we can add these three measurements up together because we know these three. And those will add up to 297. So 297 plus our x degrees, it's our unknown, we don't know, will equal 360. So we can circle our variable, draw our t. To review how to solve an equation, the opposite, to cancel out 297, we need to subtract 297. And the 297s cancel, bring down your x, and x will equal 360 minus 297 is 63 degrees. Okay, so x equals 63 degrees. Okay, now for our note purposes, copy this down because I'm reviewing how to solve an equation at the same time. But if you come up with a different way when you do your classwork, that is perfectly okay. You don't need to write it like this when you work on your classwork. So number 2, we have 103 degrees, we have 80 degrees, we have 97, and we have x. It doesn't matter which way I add them up. So we'll just go 103 plus 80 plus 97 plus the missing angle is going to equal 360 degrees because we know there are 360 degrees in a quadrilateral. So now we're going to add up the three measurements that we know, and those of course add up to 280 plus x equals 360. And we're going to circle our variable, draw our t. So to get x by itself, we have to subtract 280 from both sides. The 280s will cancel. Bring down your x, and 360 minus 280 is 80 degrees. So our missing angle is 80 degrees. And our last one here, okay? We have 56, 124. We have a box in the corner here, so how many degrees is that? Good, 90. And then we need to find B. And I know it looks like B is 90 degrees right now, but let's double check it. So 56 plus 124 plus 90, even though it's not written in there, we can tell it's 90 because it has the right angle box in there, plus x equals 360. So once again, we're going to add up the three measurements that we know, and that gives us 270 plus x equals 360. Circle your variable, draw your t. And the opposite of 270 is subtract 270. These cancel, bring down your x, and 360 minus 270 is 90 degrees. So I showed you the entire process of going through this because I wanted to review how to solve an equation, because anytime we're looking for something that's missing, there's always an equation involved. So remember, when you do your classwork on these problems, you can do it however you want. You don't have to do all this work as long as you come up with the correct answer. Okay, so let's look at below. So we have to find the missing lengths. So we're going to use our knowledge of properties to find the missing lengths. And if you look at number 4, these are congruent, which means they're exactly the same length because they have the same hash marks or hatch marks. So that's 12. And if you look here, this is 4, and this is also 4 because they have the same hatch marks. Opposite sides are congruent in a rectangle, and this is also a parallelogram. So that's true of any parallelogram. Opposite sides are congruent and parallel. So number 5, square, they all have the same hatch mark or hash mark. So if this side is 4, that means all of them are also 4. And once again, it's also a parallelogram. And remember, a square is not only a parallelogram, but it's a rectangle because it has 4 right angles, and it's also a rhombus because it has 4 congruent sides. Number 6, this is a rhombus, and notice they all have the same hash or hatch marks, so that means they're all congruent or equal, so they're all going to be 6. And this is also a parallelogram because opposite sides are congruent and parallel. Number 7, the only name other than quadrilateral is a parallelogram because opposite sides are congruent, same hatch mark, and opposite sides are congruent here and also parallel. But this one is not the same picture as this one. This one's a rectangle because it has 4 right angles. This one is slanted, so this is not a rectangle. This is just a parallelogram and a quadrilateral. Number 8. Okay, this is a trapezoid. So we notice we have 5, 10, and we have 7 here. And because this side is congruent to this side, I know because of the hatch mark, if this side's 7, this side is also 7. Okay, turn the page and let's look at lines of symmetry, which is the second half of this video. So a line of symmetry divides a figure into 2 congruent parts. Each side is a mirror image of the other. Some quadrilateral shapes have lines of symmetry. These can be horizontal, vertical, or diagonal. Okay, so I want you to think of a rectangle, and when we fold it, it should be exactly the same. It should fold over perfectly and lie on top of each other. So a rectangle has how many lines of symmetry, do you think? Hopefully you were thinking 2. And it has a vertical and a horizontal line. And when we make lines of symmetry, we use a dotted line. So try to find the halfway point, okay, approximately, and find the horizontal halfway point. And hopefully you're using a ruler when you do this. I can't exactly use a ruler here. Okay, so notice it divided it in half here. I know it doesn't look perfectly, and it divided it in half here as well. I cannot fold it diagonally because it would not overlap perfectly. Okay, so let's look at a rhombus. A rhombus has how many lines of symmetry? Good, it has 2 lines of symmetry, and it's 2 diagonal lines. We're going to draw them in. Remember to use a ruler. I'm going to try this a little differently, hopefully. Try to get a little bit straighter here. Okay, and then draw the other diagonal. And notice we have 2 equal shapes here, 2 congruent parts. Okay, so a square has how many lines of symmetry? 4. It has 4 lines of symmetry. It has a vertical, a horizontal, and 2 diagonal lines. So we're going to draw our vertical lines in first here. So I'm going to try to find the halfway point. Okay, and now I'm going to draw my horizontal line in. And now finally, I'm going to draw my 2 diagonal. Okay, so notice we have vertical, horizontal, and 2 diagonal, so a total of 4. And then the last one that we have here is a special kind of trapezoid. It's the only trapezoid that has lines of symmetry, and that's a isosceles trapezoid. Has how many lines of symmetry do you think? Good, I can only cut it in one place, and that's a vertical line. So I'm going to draw one right down the center. Okay, that concludes our notes on quadrilateral angle and side measures as well as lines of symmetry. I hope you have a great day.